All right, guys, this is lecture two. Lecture two is going to be balancing equations. And before we start into balancing equations, which is what we talked about at the very end of our last slide, I want to talk about the approach, okay? But in a different way, not in a way of steps yet. I want to talk about mindset, okay? So balancing equations is often a point of frustration for students, but I have never met a student that cannot do this. Okay. What you need to do in order to minimize your frustrations, number one, use a pencil with an eraser. Or if you have a whiteboard, use a whiteboard and do scratch work. Number two, and this is where people get frustrated. Number two, erasing is not only okay, but it is expected that you will have to erase something at some point. And that is because, number three, balancing chemical equations for 98% of people is a trial and error process by design. If you have to erase something, you are not doing it wrong, you just haven't finished the problem yet. And I'm going to show you an approach that will always work if you continue to do the process without quitting. Number four, this is not a race. Just like when we built molecules or came up with the shapes of molecules, some people can just see it in their head. I can balance most equations by visual inspection, but that's because I've been doing it for 25 or more years, right? It is not a race. You are not in competition with me. You are not in competition with somebody else in your class that can do it faster. Nobody gets extra points for being first. What you get your points for is being correct and for sticking with it. And that's number five. Don't quit. All of the equations that I give you will balance. Some of them just take more grit. Sometimes you will have to erase multiple times. It doesn't mean you can't do it. It just means that you're not finished yet. Don't quit before you finish. So that's my little spiel about attitude going into this, okay? So now we're going to talk about what it means, and then we're going to actually do some problems, okay? And these are all in your notes packet. So the first thing though is you have to be able to count atoms. And if you have not already done your 22.0 counting atoms activity, you either did it in class if you were a Monday, Tuesday person, or you did it at home with the drag and drop slide. If you haven't already done that, you need to do that before you jump into balancing equations. It is an important prerequisite skill. It will help what's on this slide, make perfect sense. So picking up on this slide, in order to follow the conservation of matter and to balance the equations, the only thing we can do is use what are coefficients. Coefficients are exactly the same coefficients like you would use in math. They are multipliers. And in our world, our coefficients are only whole numbers. So there's never going to be a decimal, there's never going to be a fraction. We're just going to use whole number multipliers. So I'm thinking about that last example that we did in lecture one before we dropped off, right? And that was 2 HCl. Remember, it was 2 HCl molecules. So that 2 that was in front meant that I had 2 hydrochloric acid molecules. And so what that means is that I have 2 H's and I have 2 Cl's. Okay, it's just a multiplier. Think about what it really means, right? It means that I have 2 of these molecules. And sure enough, that is 2 H's and 2 Cl's. Now, what if there's parentheses, like those polyatomics that we learned? Okay. Well, break down what it means. If I have as part of my formula NO3 2, right? This 2 on the outside, we know means that I have 2 NO3s, right? I have that twice. If I have 2 NO3s, what do I have? I have 1, 2 nitrogens, and I have, here's 3 and 3 more. 3 plus 3 is 6. I have 6 oxygens. So this NO3 2 means 2 nitrogens and 6 oxygens. So if I come along and I put a coefficient in front, I still have 2 NO3s, but now I have twice that many. So it's 2 NO3s times 2. So really, now I have 4 NO3s. So again, you can tally them up if you want, or you can distribute it like you would in math. But if you look at this, right, I have 1, 2, 3, 4 nitrogens, and now I have 3, 6, 9, 12 oxygens. And here I can do the same thing, right? I have 2 nitrogens twice. That's 4, okay? I have 2 O3s twice. That is 12 because it's 6, and then twice is times 2 is 12. So however it is you need to count them, you need to count them. But if you haven't done the 22.0, please stop the lecture right now and make sure that you go back and do that first, because that's going to make the rest of this make much more sense. So when correctly balanced, the coefficient should be the smallest whole numbers possible. Oops, sorry, went too far. The smallest whole numbers possible. So I'm going to keep on talking about this example that we did. Okay, I want to be consistent for you. Okay. If it is properly balanced, it takes 1 H2 and 1 Cl2 to make 2 HCl's. It would still technically look balanced, but it wouldn't be proper if I had written that it takes 2 hydrogens and 2 chlorines to make 4 HCl's. While this would physically be true, the correct way to do it is the lowest ratio. So just like when we did ionic compounds, we were looking for the lowest ratio in our ionic compound. In a balanced reaction, we are looking for the lowest ratio of all of the different species. Okay. So again, remember, please use a pencil and scratch paper. Give yourself plenty of room to work. Keep going and don't quit. It's trial and error. It's okay to erase. You haven't done anything wrong. You just aren't finished yet. And then the last one is what we're going to focus on now, which is recognize when you can use the tips to make things easier. So what you have in your notes now is a set of different types of reactions to balance. And what I'm going to do is I'm going to go through and balance all of these on the slides. And I'm going to talk a lot while I do it. And I know sometimes that's boring, but guys, you need to understand the process, okay? So what I want you to do is not just write down the balanced equation once I'm all said and done. What I want you to do is to think about what else could you write down. I gave you a place in your note packet to do this. What else could you write that might be helpful? What kind of helpful information? So like on this very first slide, since we haven't done any yet, I would say the first thing that you need to know is that you need to make a list, right, of all of the elements that you see on the left side of the equation. Okay. So I'm looking here and I see nitrogens and hydrogens. So when I say make a list, I mean literally make a list, okay? And then you're going to make the same exact list on the other side of the arrow, because I'm not going to magically create new atoms, right? So make a list of the elements, right? Then copy that list over. So that's what I mean. I made a list and then I copied it over. Notice they're in the same order. That's really important. That's why I want you to literally copy the list and just write it twice, once on the left side and once on the right side. Okay. Now, the next thing that you're going to do every time is you're going to count the atoms in the equation. Okay, now when I go to count the atoms in the equation, I'm going to keep a tally down here in my list. This list is a tally. Okay, it is scratch work. It really doesn't mean anything to anybody but you when it's all said and done, because you can balance equations starting with any element you want and then do it in whatever order you want. I'm going to teach you some approaches that will make it easier, but really this is scratch work. Okay, so first thing I'm going to count. So here I have N2. That means I have 2 nitrogen atoms, and I have H2. So that means I have 2 hydrogen atoms. Over here I have 1 nitrogen and 3 hydrogen. So I made a list. That's always the first thing. And then I counted them up. That's always the second thing. And then the third thing, this is where you start to have a little more freedom. The third thing here is I like to pick something easy to do, okay? So pick something easy. And I'm going to say to fix. I don't know what else to call it really. So pick something easy to fix. Remember that the only thing that we are allowed to do is we are allowed to put a coefficient in front of anything in the balanced equation. I'm going to put little lines here to show where I can put it. I'm not allowed to change the formulas. We just spent weeks learning how to write formulas. Okay. I'm not allowed to add things and subtract things, but what I can do is put a coefficient, which is a multiplier. So I want to pick something that I can multiply and easily fix things. So here I've got 2 nitrogens on the left and I've got 1 on the right. And I've got 2 hydrogens on the left and 3 on the right. Well, trying to figure out what to multiply 2 by to get 3, that's not a whole number, so it's not particularly easy. So I'm probably going to approach the nitrogen problem first. So what I need to do, and remember this is scratch work, this is not the answer, is I need to come up to my equation and realize that the only thing I can do is put a number in this blank. I'm going to put the number 2 here. Now because I changed this number, these numbers are going to change as well. Notice I scratched them out, right? I'm not going to count from here. I'm not going to add from here, multiply from here, nothing. I always recount from the top. So now I have 2 nitrogens and I have 2 times 3 when I distribute out. So now I have 6 hydrogens. Okay. So again, I'm always counting from the top. This is just scratch work. You can erase it if you want to erase it. You can scribble it out if you want to scribble it out. Truthfully, I scribble mine out. I only erase up here, but you can do it however works for you. Okay. So I took care of the nitrogen problem. I now have 2 and 2. So then I go and see, well, did that make the hydrogen problem any easier to manage? And it did, because now I have 2 over here and 6 over here. And I'm looking up here where my hydrogens are, and I realize, you know what? All I have to do is put a 3 there, and 3 times 2 is 6. So I have 2 and 6, and 2 and 6. So that means that this is now balanced. Now this is how this molecule actually gets formed. It takes 1 nitrogen and it takes, I'm going to color these in here, it takes 1 nitrogen molecule for every 3 hydrogen molecules. And in the end, what I end up with is I will end up being able to make 2 NH3 molecules with all of my atoms accounted for and the same number on both sides. This is what balancing equations is. So I'm going to go through the next one. Now look at this one. It looks like there's a lot more going on, right? So that's okay. What I'm going to do here is I'm going to have the same basic approach. I'm just going to make a slight adjustment. So let's talk about what that adjustment might be. I need to count these things up, and I see silvers and nitrogen and oxygen and calcium and chloride. So there's a lot going on here, and I would really like to not have a really long list. So this is my hint for when you notice that you have polyatomics. If you have a polyatomic and it is the same, exactly the same, it can't change at all. If it is the same on one side as it is on the other, one thing that you can do is to make it easier is you can count polyatomics instead of counting individual nitrogens and oxygens. Okay, so you're going to count the polyatomics. Now this only works if they stay the same on both sides. So here, that's why I put this one in parentheses so you could see it easier. So I'm going to make my list just like before. I have silver, I have nitrate, I have calcium, and I have chlorine. And on this side, I have the same things, and I'm going to write them in the same order because that helps keep it straight. Then I'm going to count. So when you go to count, again, you come up here, there's 1. Here I have 1 nitrate, 1 calcium, and 2 chlorines. Over here, I have 1, and see how this 2 is on the outside? That means I have 2 nitrates. So just put 2 there. 1 calcium, 1 chlorine. So there's my tally. Now from this point forward, I'm going to do pretty much the same thing. I'm going to pick something. You can pick the NO3s to fix first, or you can pick the chlorines. It literally makes no difference at all. So please don't feel like you are doing it wrong if you immediately think to do something different than what I'm going to do. Okay. I'm going to pick chlorines. Okay, so I've got 2 on the left and 1 on the right. So I come up here and find the chlorine, and I go put a 2 in front. Okay, now I recount. That's going to give me 2 silvers, so I'm going to scratch that out and put a 2. And it's also going to give me 2 chlorines. So come down here and I scratch that out, and it gives me a 2. Okay, so I fixed the chlorines, but now my silvers and my nitrates don't work. So I need to come over to this side and get more silvers and nitrates. So I find them, they're right here. I need 2 silvers, put a 2 right here. Now I recount, scratch that out. I have 2 silvers, and then look at this, it took care of itself. I have 2 nitrates. So 2, 2, 1, 2, 2, 2, 1, 2. Now you could have started with the nitrates, you would still get the right answer, guys, as long as what you're doing is counting always from the equation at the top. Okay, let's try another one. Okay, this one has a polyatomic in it, just like before. So let's kind of highlight that polyatomic. I see SO4 over here on the left-hand side, and I see exactly the same SO4 on the other. So that's helpful. I can count H's and SO4s and K's, and oh, look, there's an H here and here. That's kind of weird. And there's a polyatomic here. It says OH, but I don't see an OH over here. This is the water trick. Okay. You can rewrite water as HOH. So it doesn't always help, but since I have an OH here, I think it will help me this time. So I'm going to cross this out, and I'm just going to rewrite it as HOH, because now I can count OHs. So when I go to make my list, I'm going to have hydrogens, sulfates, potassiums, and hydroxides. And I have the same stuff on this side. Hydrogens, sulfates, potassiums, and hydroxides. Now, if I've lost you, please just back up a little bit and look again. Okay, it's hard to teach this virtually, but you guys can do this. I know you can. Now we're going to count, okay, and you just have to be careful. So here I have H with a 2, so that means 2. I only have 1 SO4 in this formula. I only have 1 K, and then I have 1 OH. Now on this side, there's my 1 H. There's my 1 SO4. Oops, there's 1. 2 Ks and 1 OH. So again, you guys can pick whatever you want to fix first. It does not matter. So this time I'm going to start at the top just because I can. So I have 2 H's on one side and only 1 on the other. So I'm going to come up here and find the H. It's here in the water. I'm going to put my coefficient in front. Now I'm going to have 2 H's. So scratch that out. And I'm also going to have 2 OH's. So scratch that out. Okay, so that fixed one thing, but that was it. I need to have more potassiums and more hydroxides on the left. I need to have 2 of each. Well, so I come and find them and I put a 2 there because it's a multiplier. That gives me 2 of these, right? And it also gives me 2 of these. So I've got 2, 1, 2, and 2. 2, 1, 2, and 2. So this one is balanced. So if it helps, rewrite your water as HOH so you can count OHs. If it doesn't help, don't do it. Okay? All right, let's try another one. Again, you can see this one kind of looks like there's a lot going on, but I want you to go really systematically through what you have here. This is why we did all of the formula writing first. So I would know what I'm looking at. I'm looking at a phosphate on both sides. So I'm going to keep that together. And here I have a hydroxide. I don't have one, but if I write HOH, I will have one, right there. So when I'm making my list here, I only have 4 things. And most of the time, you can keep your list to 4 or less if you pay close attention for things like polyatomics hiding in there. Okay, so once I've got my list, I'm going to count. Here's my 3 hydrogens, just one of those PO4s, just 1 calcium, and 2 hydroxides. Over here, 1 hydrogen, 2 PO4s, 3 calciums, 1 hydroxide. Pick anything you want to start. It totally does not matter. I would pick something easy. These are all equally easy because I can put something pretty much anywhere and fix something. So let's see. Maybe I want to fix the calciums first this time. I have 3 of them on the right. I need 3 of them on the left. So I have to find them up here and see what do I multiply by so I can get 3 of them. So put a 3 here. Now I have 3 calciums. But look what I just did. Now I have 3 OHs times 2. So that's 3 OHs times 2. That means I have 6 OHs now. All right, well that fixed one thing, but it did not help me in the other areas, but that's okay. So I can either fix my OHs or my H's or my PO4s. It really doesn't matter. Okay. Maybe I'm going to go with trying to fix my PO4s. So I need to have more of them on the left. So here I go. I can put something right there. I need to have 2 PO4s, so I'm going to put a 2 here. But remember that messes everything here up. So I've got 2 times 3. That means I have 6 hydrogens now. And I have 2 times 1 PO4, 2. All right, so my PO4s are good, my calciums are good. What's not good are my H's and my OHs. I need 6 of each. Well, if I put a 6 right here, I'll be good to go. So this one is a little bit harder. And again, I know I've got all this little scratch work up here, but I'm trying to kind of show you my thought process as I go along. You don't need to write all of this scribbly stuff down up here unless it just helps you, but you should keep a tally. Don't try to keep it all in your head. It's just complicated for people to do that, and it makes it unnecessarily difficult, okay? And if you find that your numbers are going up and up and up, 6 is pretty big, but if you start to notice, I've got huge numbers and they just keep getting bigger and bigger and bigger and I can never get it balanced, chances are you've just counted something wrong somewhere along the way and now you just keep multiplying that error. So the best thing to do is just erase everything and start over, maybe even do a different one and then go back to it. Because that does happen sometimes. And this is a really good example of that. This is a really tricky one. So I'm even going to give you a warning that this one is tricky. Okay, but again, just because it's hard doesn't mean that you can't do it. Okay? It just means you have to have patience and grit. So first I'm going to look for all of those little things. Is there a polyatomic on this side that's exactly the same on this side? The answer is no. I have CO on this side, but it's CO2 over here, and that is not the same. So I can't count COs or CO2s. I have to count them separately. So I have to make my list. So my list, I have iron, oxygen, and carbon. Make the same list, copy it over. Now here's where this one is a little bit harder. Okay, so the reason this one's a little bit tricky is because of this plus sign and the fact that I have oxygen in 2 different places. It's easy to see I have 3 of these. And it's easy to see I have 1 carbon, but what you need to see is that here you have 4 oxygens plus this one over here. So my tally is 5. Come over here, I have 1, 2, and 1. Okay, so there are 2 different ways to do this. Both of them totally work. You can muscle through this. Okay, if you are not particularly good at it, you can muscle through. Now, when I say muscle through, what I mean is outright trial and error. Start with small numbers. Go to 2 if it doesn't work. Go to 3 if it doesn't work. Go to 4 and so on. Don't start with great big numbers. Work your way up because remember we want it to be the lowest ratio. So you can totally muscle through this one. The other thing that you can do is you can look for the lowest common multiple. If this freaks you out because it's a mathy term, then don't worry about it, okay? Just muscle through. But I'm gonna work on solving this one. So most students, the first thing they do is they go, oh, I'm gonna put a 3 right here, which is perfectly fine as a place to start. It does get your irons balanced. The thing is that irons out there by itself, I can put any number I want to out there at any point, and I'll have as many as I need. The bigger issue is this whole C and O thing, right? The C's look okay, but geez, look at these O's. I've got 2 on this side and I've got 5 on this side. Okay, I'm going to do the muscle through way first, and then I'll talk about the lowest common multiple. So the muscle through way would be to say, I have 5 on the left, I only have 2 on the right, so I have to have more of them on the right. So here's my thought process. I could put a 2 here, right? If I put a 2 here, I would have 2 times 2, and that would be 4, which is still not enough. But I could put it there, right? And if I did, I would have 4 and I would have 2. But then I would realize, ugh, that's not enough. I have to have at least 5. So I would have to erase this. And I would have to go just bump up to the next number. So if that wasn't enough, I would try a 3. That would give me 3 of these C's, and now it gives me 3 times 2. It gives me 6 O's. So now I've got more O's on one side than I do on the other side. So again, I'm going to come over to this side and say, well, how am I going to get either 3 C's or 6 O's, or at least more O's, right? I don't know how to get 6 O's from this. So maybe what I'm going to do is worry about the C's instead and hope it works out. So I'm going to put a 3 here, and then I'm going to recount. Now I have 4 O's plus 3. Well, 4 plus 3 is 7. That's not balanced. Now I need more O's on the right side. I'm not going to jump up too big. I'm going to do this muscle through way, right? So what I'm going to do is I'm just going to come right here and I'm going to go to the next number. So I did have a 3. Now I'm going to put a 4. So that's going to change the carbons again. And now I have 4 times 2. Now I have 8. Geez, right? You're like, how many times do I have to erase this? Well, the answer is until it's balanced. I'm looking over here. Now I need more C's and more O's. Well, I'm going to keep going here because that's the only place I see a C. So again, I'm using the muscle through method. I need 4 C's, so get myself 4 C's. Now I have to add up again. These 4 plus 4. Finally, right, I have 8. So this is kind of the muscle through method. This works, okay? It's just not the easiest thing to do. You can look for lowest common multiples, which is sometimes a really easy approach. Sometimes it works and sometimes it doesn't. In this case, the thing that made this hard was this guy right here, right? So talking just about math patterns, so you can ignore me now if this is how you plan on doing it and muscling through, that's great. But if you're a little more mathematically inclined and you're looking at patterns, I'm going to talk to you for a second about patterns. Okay. What I noticed when I first counted these up was that on the right side, I had O2. And no matter what number I put in front of it, I'm going to have an even number of oxygens on the right side. When I look over here on the left-hand side, I have 4 plus 1. This oxygen was the problem because it kept making my total odd, right? So what that tells me is that I need to have an even number, which meant that this had to be an even number. So I could have tried a 2 and then gone up to the next even number, which would have been a 4. Now, if you don't see a pattern like that, that is 1,000,000% okay, guys, because as you see, the muscle through method will work for you every single time. So don't worry about it, but you could look for patterns. But if that freaks you out, not necessary at all. Okay, let's see. I think this is the last one in our note packet. This kind of problem is the kind that has the biggest numbers, right? Usually the numbers are fairly small. They're usually like 5 and under. But in this case, because there's some big numbers in the problem, in the formula, that 10 is a pretty big number. It means I'm going to have some big numbers in my equation, right? So this is a combustion problem, and we'll learn about combustion problems next week. But in a combustion problem, what you kind of want to notice is that, pen isn't working for a second here, guys, is that save the O2 for last. Okay, so just like before, I said I could have put any number I wanted on the iron because it's by itself. Well, here, oxygen's by itself. So I can put whatever number I want to on the oxygen without messing up the other stuff. So I like to save it for last. I don't really need to make it play nice with the other atoms because it's all by itself. So this particular equation, I have C's, H's, and O's. Changing my water to OH is not going to help me at all because there is no OH on this side. And I've only got 3 elements to deal with anyway, so it's not too bad. Okay. So here, again, my tallies are going to start off kind of big. C4, H10, O2. And over here we have C1, H2. And again, here's that pesky plus thing. So this is 2 oxygens plus 1 more. So that's 3. All right. And again, I'm saving the oxygen for last. That's what I always do with this kind of problem. I'm going to worry about the C's and the H's. So whichever one you want to do first, that's the one you should do first. It doesn't matter. I'm going to just start at the top. So I see 4, I need 4. So I'll put a 4 here. Again, I have to erase or cross these out. And now look what this is. 4 times 2 is 8 plus 1. Ugh, right? That's 9. That is not pleasant. So I'm thinking, but I don't even know what to do with the oxygens. Maybe, and this is totally okay, maybe this freaks you out and you're like, oh, backtrack, I don't want to do that. That's okay too. Maybe I changed my mind. I don't want to do the carbons first because it didn't play nice. That's okay. You're allowed to erase. Maybe I'm going to say, let me try this instead. I'm going to try my hydrogens. So I'll put a 5 here. That gives me 10 hydrogens. What's that do to my oxygens? So I have 2 plus, here's 5 times 2. 2 plus 5. So 2 plus 5 is, man, that doesn't help either, right? That's a 7. Okay, so again, not helping. So back to the carbons I go. I'll put the 4 back. That gives me 4. Now, 4 times 2 is 8. 8 plus 5 is 13, guys. 4, 7, 13. This is not working the way that I want it to. My numbers are getting big down here, and there's literally no way I can make it work. Well, here's the big clue, okay? If you get your C's and H's balanced, or your C's and H's close to balanced, right? And there's no way to fix it, okay? There's no way to get 13 H's. You can't. It's not possible. Here's your clue, right? Do times 2 on the CH side, okay? So right here, I'm going to put a times 2 because what I see happening is I have to get more hydrogens anyway, and I can't get 13, right? So I might as well the smallest number I could do is a 2. So I'm going to put a 2 here. Now it's going to make my tallies really big, right? It's going to make them 2 times 4 and 2 times 10. Those are huge, but that's okay because all I'm doing is doubling everything. So now I need 8 C's. So again, we're going to, oops, not do that. I'm going to erase again. I got a lot of stuff going on here, so I'll erase a lot of it. And then try again. 8 carbons. Makes me a little nervous, but what can I do, right? Okay, so 8 times 2 is 16. 16 plus 5, I don't know, what is that, 21? That's not helpful. But I need 20 hydrogens. So let me just worry about the hydrogens and not even worry about anything else because I can erase this, right? So I'm erasing, erasing, erasing. How on earth am I going to get 20 hydrogens? Well, it turns out it's not that hard. 10 times 2 is 20. Okay. Ugh, I don't even know where that 21 came from. See, I counted wrong, guys. So this is 20. How many oxygens do I have? I have 8 times 2 is 16. 10 times 1 is 10. 16 plus 10 is 26. Wow. I've got 8 and 20, and I need 26. Everything's good except for the oxygen. So what can I multiply oxygen by to get 26? 13. Okay. So these are big numbers. They are. Makes me nervous. I need the lowest ratio. So if you're nervous about it, that's okay. Just come up and look at your coefficients and see, can you divide them all by a number and have it still be balanced? Well, the truth is that I can't divide them all by any number because this is 2, 13, 8, and 10. And I can't divide the 13 by 2 because I don't get a whole number. So the 2, the 13, the 8, and the 10, that is the lowest ratio, even though it's kind of big. But it makes sense it's big because H10, well, that was big to start off with. These are probably the hardest ones. And again, you can see muscle, muscle, muscle through it here. I made a little addition mistake, but because I was concentrating on the other things, it worked out. If it hadn't worked out, the thing to do would be erase it all and start over. Okay, so you've hung in there to the end. I've walked you through all of these. I hope that you've written some notes on your paper on some strategies that we used as we went along. The bottom line here, guys, you have to practice. In order to obtain mastery, in order to get good at something and own it, you have to practice. So our next worksheet is practicing balancing. Okay. You will never get good at this if you don't do the work. So use a piece of scratch paper, do it on paper at home, right? And then type your answers in because the truth is that your scratch work doesn't mean anything to me because maybe you did it in a different order and that is okay. But you have to actually do the work, okay? So work on them, get them in by the deadline, and then if they're not correct, I'll be able to tell you and maybe point out any errors or what's not quite right about them so that you can go back and practice some more, okay? So thanks for hanging in there. This was kind of long, but I really wanted you to hear how I was thinking as I was doing it because you should be having that inner dialogue with yourself while you do your practice.